Alright, today let's understand and do the hands-on for S3 query select. So this is very important because you might be confused, like why do we need S3 select when we have Athena, right? So here we got to understand that S3 select, the most important thing is that it is good for simple select statements. It's not meant for complex queries like multiple joins and complex very long queries, because we have a maximum length as well here, right? We cannot go ahead and with 10,000 lines of codes and all. The first point to keep in mind is that the permission. If you're facing trouble using your S3 query select, then probably you might need this GetObject permission so that you can use the S3 select feature. Now, second important thing is the data format, like what should be your file format or the object present in the S3 which you can utilize for S3 query select. Just like there are three currently supported, that is CSV, JSON or Apache Parquet. Let's say you have uploaded Avro format and you're trying to do S3 query select, it might not work because currently as of today only three formats are selected, right? So the third point I've already explained, that there is a limit for the SQL expression which you can form, and the maximum length is 256 kilobyte. Then comes the fourth point, that is last but not least, that is the output format. The output will be either CSV or JSON. We'll be doing everything from the scratch in the hands-on just now, so please follow along with me. So we are in the AWS console. Let's go ahead by clicking on S3 because we need to create a bucket first. Let's click on create bucket button. We got to name our bucket. We got to name a unique name, that is global namespace as mentioned. So this looks good, the bucket name. Let's go down. I'll keep everything as default. I won't toggle anything. I'll just simply click on create bucket. We are creating bucket because we need to store the input file which we want to use the S3 select, right? So let's go ahead by clicking on the recently created S3 bucket. So this is our bucket. Currently it hasn't got any object. So let's upload a file from our local computer. I have the company file which is in .csv format, because if I look here, and this is what the data looks like. So I have total of 25 rows including the header, that is the count will be 25, and this is the data. It looks something like this. Now let's try to upload this file in the cloud. I'll click on the upload button. Now let's click on add files, and here let's browse our company.csv file. We can see it's comma separated values file, that is CSV file. Let's double click on it. We'll need to check it. Now let's go down. We'll click on upload. All right, our object got uploaded. Remember, whatever file we upload in S3, it is known as object because S3 is an object storage, right? So we got to call it as object now, and we got our file here, that is the object here. Now looks good. So here I got to check it here, and here we under the actions I'll be having query with S3 select. Let's click on it, and here if you look, it has by default selected the format CSV. If I look at the extension of my file, it has got .csv. So we need to select the correct input settings before querying, right? So our format is CSV, looks good, and delimiter, that is comma, because CSV by default we know that the name implies comma separated, right? So the delimiter is comma. If you're not sure like what is your delimiter, sometimes it can be tab as well, not for the CSV but for other formats. You can, how do we check it? We can open the file in Notepad in Windows. All right, I've opened the company file using open with Notepad, and here if you look, the delimiters, these are the delimiters, that is column names are separated by commas, and everything, the values, each and every value is separated by a comma, right? So this is your delimiter. Remember, it can be a tab as well, it can be space as well. depends upon how your file looks like. So I'll click on close for now. And if you have any kind of different delimiter like caret or asterisk, anything, right, as per your business requirement, you can use it. But the standard format is CSV and tab we generally use. That's why AWS has provided these formats for easy go. Now here we got the compression. For CSV there is no compression for us, but for Parquet you might have compression. You can select as per the requirement of your business. Here if you go down, we got the output settings. Remember, in the theory part what we have learned, the format can be CSV and JSON. Just to show you here the output formats, it can be CSV or JSON, right? So that's what we are able to see in the hands-on as well, that the result can be either CSV or JSON. So we'll try it out with now CSV for the output, and for the input, remember it has asked us for these formats, right? So this theory, remember, always match the theory concept with hands-on. It will solidify what you have learned. So now let's go back to the AWS console. So here if you look, I am here, the delimiter I have selected comma, and I want the output in CSV, right? So here by default it has got the it forms the basic command, that is the select command. In SQL, just like we have select star from the table name, here by default it will be the S3 object, that is your treat it as your company file which you have just uploaded. This is the table name, and limit, just like in SQL as well, we have the limit and the top command, like how many rows you want to select, it will use. By default it's 5. So let's go ahead and click the run SQL query. It's running here and it has result successfully returned. If your syntax is not correct, it will throw in red and give the same thing that your syntax doesn't look good. So here if you look, it has returned the 5 rows from the top, and including the header. If you look now, if I go to formatted, I'll get a quick nice view of. I can also download and export the results. Remember, I can export the results in two formats, CSV or JSON. If I download the results, let's click on download results. The file is downloaded. Let's open the file. So if I open the file, if you look, it has successfully exported what we are seeing in the AWS console, that is the 5 records, right? So this looks good. Let me close it. Now let's see some more thing in action. We got some SQL templates as well. If you are not familiar how to write this syntax, because it's a little bit different from what SQL statements is, I can click on add SQL from templates. I can quickly use some select count star. These are some common SQL commands. I can copy it. If I copy it, I need to delete it and paste this manually. If I append SQL, it will just put this at the bottom here. I need to remove this. Let's remove it and run the SQL. If I run the SQL, see, I got the 25 rows. Why 25 rows? Because if I look at my input file, it has got 25 rows including the header, right? So technically it's throwing this the count of the records, how many records it has. So this again looks good for us, and I hope you found this S3 select feature as easy, and thank you so much for watching this video. Alrighty, so let's look at this question, and we need to choose an option with least operational overhead. If you look at option A involves extra operational steps of creating and maintaining a separate table for non-sensitive data, increasing complexity. We'll remove option D on that basis. We'll move to option B. Option B, if we look, and option C, Redshift doesn't support the column level permissions through grant select command, as well as managing IAM policies for column level access, which is not supported by AWS Redshift. So we can reject option B and C as well. we are left out with option D. Option D meets the requirement with least operational overhead. That being said, D is the right answer. We'll log this. Alright, now let's look at this question, and we need to choose an option which supports orchestration of Python and Bash scripts without necessitating any code refactoring with least operational overhead. You look at option A. AC is AWS Fargate. AWS Fargate does not orchestrate data pipelines or scripts without additional setup. Let's eliminate this. We'll move to option B. B says Amazon managed workflows for Apache Airflow, also known as Amazon MWAA. MWAA provides fully managed orchestration service which supports Python as well as Bash scripts, eliminating server management and avoiding code refactoring. Let's park this. Let's move to option C. C is AWS Data Pipeline. AWS Data Pipeline is a managed service but requires more configuration and management compared to Amazon managed workflows for Apache Airflow, which was option B. Since option B for now is better than option C, we can reject option C for now. Now let's move to option D. D says AWS Glue. Glue we know is focused on ETL tasks and may require refactoring to support existing scripts without additional overhead. That being said, AWS Glue is again a wrong choice because there is no requirement of such kind of like ETL and all, right? So we are left out with one option, that is option B, and we'll log this. All right, now we got an interesting question, and this time we need to select an option where needs SQL join queries on S3 objects, and it should be a serverless solution. Let's look at option A. A says Amazon S3 Select. S3 Select does not support complex queries like SQL join across multiple buckets. We'll eliminate this. Easiest way to remember how S3 Select can be the potential answer. If there is any kind of complex join queries and all, S3 Select will be incorrect. If it is a simple select statement, then S3 Select might be the potential answer. But for this case, since join is involved, which is kind of complex query, we will reject S3 Select for now. Let's move to option B. B says Amazon Redshift Spectrum. Redshift Spectrum requires a Redshift cluster, which may not be the most cost-effective serverless solution. We'll reject this. Let's move to option C. C says Amazon Athena. Amazon Athena provides a cost-effective serverless solution with support for partitioning and maintaining ACID properties. ACID stands for atomicity, consistency, isolation, and durability properties. If you're into RDBMS or database related stuff, you might be familiar. So ACID should be on your mind. So for this, Athena looks good. Let's park this. We'll move to option D. D says Amazon Elastic MapReduce, also known as EMR. Elastic MapReduce would involve additional management and higher cost compared to Athena, which is serverless. That being said, D is out. Let's lock option C as the right answer. Alrighty, we got a brainstorming question, and here we need to enable AWS data migration service to replicate data between two AWS data stores. Let's look at option A first. Option A, if you look, this option allows AWS data migration service to replicate data to Amazon Redshift cluster in the target account and region. We'll park this. Let's move to option B. Option B, if you look, the replication instance should be in the same region as the target database, that is EU South 1, right, to minimize the latency and ensure efficient data transfer. On that ground, option B is wrong. Let's move to option C. Option C, if we look, using a new AWS account complicates the setup without any additional benefit. It should be in the target account, that is account Y. Let's eliminate this. Let's move to option D. Option D, if we look, the replication instance should be in the target account, that is account Y, not X, to facilitate the data transfer to the Amazon Redshift cluster in the EU South 1 region. That being said, D is also wrong. We'll lock option E as the right answer. Okay. So here we got to select a solution without increasing cost. That is, we need to minimize cost. Let's look at option A first. Option A, if you read this, utilize a provisioned Amazon EMR cluster. So using provisioned Amazon EMR cluster adds additional cost and complexity. As per the question, the goal is just the opposite, without increasing cost. Therefore, we'll reject this. Now let's move to option B. Option B, if you look, parallelly load all the data files to Amazon Aurora, subsequently execute an AWS glue job to transfer the data into Amazon Redshift. Loading data into Amazon Aurora and then using AWS glue adds extra steps and cost. Incorrect choice. Let's move to option C. C says parallel load all the data files into Amazon Aurora, subsequently execute an AWS glue job to transfer the data into Amazon Redshift. Using AWS batch is unnecessary and adds complexity and cost. So this is again wrong. Let's move to option D. Option D, this option allows for efficient data loading in a single operation without additional cost or complexity. That being said, option D is the right answer. We'll log. All right, now this question will test your concepts on security and networking. Option A, if you look, says generate new security tokens for the transfer family server. Ensure both old and new tokens are accessible. Generating new security tokens does not ensure encryption via TLS 1.2 or higher. Let's eliminate this. We'll move to option B. B says update the firewalls. Updating the firewalls does not impact the encryption protocols used by the transfer family server. Again, wrong choice. Let's move to option C. C says modify the security policy of the transfer family server to enforce a minimum protocol version of TLS 1.2. This option ensures that the server uses TLS 1.2 or higher for encryption. Looks good. We'll park this. Now let's move to option D. D says deploy an SSL certificate on the transfer family server to secure data transfers with TLS 1.2. Installing an SSL certificate alone does not guarantee the enforcement of TLS 1.2 or higher. That being said, option D is incorrect. Let's lock option C as the right answer. All right. We got interesting question, and this question we need to provide a solution with lowest management burden. Let's look at option A and C. Both option A and C uses Kinesis, but if you read the question, there is no mention of real-time data or streaming data in the question, right? That's why we don't need Kinesis. Let's remove this. Now let's move to option B. B says AWS manage Kafka streaming, known as AWS MKS provision cluster. AWS managed Kafka streaming requires the user to manage the provisioned infrastructure, which increases the management overhead. Therefore, again, wrong choice. Now let's move to option D. D says AWS managed Kafka streaming, AWS MKS serverless. This option offers the lowest management burden because it is a serverless solution, meaning AWS handles the scaling, patching, and other infrastructure management tasks. That being said, option D is the right answer. All right, now we got an interesting question. So here the pipeline needs to handle incremental data processing. Let's look at option A. A says workflows. Workflows manages and automates complex ETL jobs but does not address incremental data processing. We'll eliminate this. Now let's move to option B. B says triggers. Triggers initiate AWS glue jobs based on specific conditions but does not again support incremental data processing. So B is also wrong. Let's move to option C. C says job bookmarks. Job bookmarks in AWS glue tracks process data, enabling efficient incremental data processing by processing only new or modified data. We'll park this. Let's move to D. Option D says classifiers. Classifiers determine the schema of data sources but do not contribute to incremental data processing capabilities. That being said, option D is incorrect. And let's lock C, that is job bookmarks, as the right answer. All right, now we got interesting question, and we need to prevent accidental deletion in future with minimal operational effort in AWS. So this should be easy, because if you've done the hands-on, then this should be piece of cake basically, because this is a simple S3 feature which is expected if you're already a cloud practitioner certified. Let's look at option E. It says regularly perform manual backups of the S3 bucket. This option requires continuous manual effort, increasing operational overhead. We don't need this. Let's remove. Let's move to B. B says activate S3 versioning for the S3 bucket. Looks good, because activating S3 versioning prevents unintentional or accidental deletion by keeping multiple versions of an object in S3 bucket. Let's park this, because that is what we need, right? If we read this, prevent accidental deletion in S3 bucket. Let's move to option C. C says set up replication for the S3 bucket. This option creates copies of data. It does not prevent deletions as required by the question. Instead, replicates them. This is something different. We don't need. C is out. Let's move to D. D says move the data in S3 bucket to an Amazon S3 Glacier storage class for archiving. If you read the question, there is no need for archiving. We need to prevent the accidental deletion. Moving to Glacier will save the cost, but again, it won't prevent the accidental deletion thing. It's completely out of topic, right? Because moving to Glacier doesn't address the concern of preventing accidental deletion. So D is out. We are left with option B, and it is the right answer. Alrighty, let's look at this question. It's all about real-time data this time. Let's first tackle option A and C. Option A and C, if we look, this option introduces latency due to the periodic querying every minute, which we don't want, right? Let's remove this. We'll move to option B. If you look at option B, this option provides real-time processing capabilities, allowing for immediate detection of sudden drops in network usage. We'll park this. Let's move to option D. D says implement an AWS Lambda function using the database activity streams feature of Aurora to detect network traffic drops. This option is not optimized for handling the high throughput and immediate detection requirements of real-time data, what we need as per the question. That being said, D is wrong. We'll lock option B as the right answer. So please don't go away. Let's meet in next part of this series.